Section 310.4 of the National Electrical Code addresses conductor sizing, stating that conductors must be sized to have an ampacity sufficient to carry the load current without exceeding the allowable ampacity of the conductor, in accordance with Section 310.15 and the applicable conductor adjustment factors specified in Section 310.16. Section 310.15 details the ampacity of conductors, explaining that it shall be determined by their size, insulation type, and the ambient temperature and other applicable factors as specified in Tables 310.15b16 through 310.15b22. Although the National Electrical Code does not explicitly forbid increasing the size of one-phase conductor compared to the other two in a three-phase system feeding a motor, several practical concerns arise. Firstly, uneven voltage drop may occur. Even if calculations suggest the voltage imbalance remains within acceptable limits, differing conductor sizes inherently lead to unequal voltage drops across each phase. This discrepancy can cause the motor to run inefficiently, potentially leading to overheating and reduced lifespan. Secondly, ampacity imbalance is a factor. When conductor sizes vary, the ampacity of each phase differs. This disparity can create a situation where one phase becomes overloaded while the others remain underutilized. Such an imbalance can stress the motor windings and increase the risk of premature failure or nuisance tripping of overcurrent protection devices. Thirdly, standard industry practice dictates uniform conductor sizing for power circuits. Mixing conductor sizes can lead to confusion during installation, maintenance, and troubleshooting activities. Consistent sizing simplifies identification and reduces the likelihood of errors. When evaluating a contractor's request to use different conductor sizes, it is essential to consider the implications for safety and long-term system reliability. While cost-cutting or convenience may motivate the request, these factors should not compromise the integrity of the electrical installation. Using appropriately sized conductors matched to the load and circuit conditions is always the best approach. In scenarios where a contractor proposes increasing the size of one conductor, a thorough review of design calculations by a qualified engineer or electrician is warranted. Written approval should be obtained to ensure compliance with applicable standards and regulations. In conclusion, while the National Electrical Code may not have a specific prohibition against upsizing a single-phase conductor, it is generally not advisable due to the potential for voltage imbalance, ampacity imbalance, and deviation from standard industry practice. Maintaining a uniform conductor sizing aligned with load and circuit requirements is the optimal approach for safe and reliable motor operation.